All right. Hello, guys. Good evening. Happy Wednesday. This is our April week 3. The last lesson before we go for holiday. Okay, so I guess you guys are having a holiday already, huh? Thanks for coming because today I can foresee that there will be a lot of people missing, going on to their vacations and holiday and things and whatnot. Okay, anyway, so our lesson still continues lah. Huh? We are still proceeding. We are still continuing on our chapter 4. Okay, so I hope you guys are ready to learn. I know it's your holiday already. I know you're in your holiday mood already. But I will try not to go into anything too heavy today. Right? You just need to do some common sense stuff today. Okay? Will you do that for me? Will you do that for me? Just common sense stuff today. Just very simple stuff today. Nothing difficult or, challenging or whatever. Okay, so let's go to 4.2. Let's go to 4.2. Have I mentioned this last week, guys? I have, huh? I have, huh? Have I? Have I mentioned last 2.4.2 last week? What affects your rate of reaction? Okay, I'm just going to quickly repeat. So how do you make your reaction faster? The higher the concentration, the higher your ROR. The higher your temperature, the higher the ROR. If catalyst is present, remember what is a catalyst? Something that increases your rate of reaction. If you use catalyst, your ROR is higher. If your size is smaller, your ROR is also higher. Pressure, this is only for gas. And when pressure increase, your ROR also higher. Okay, I would like to remember the front 4 as how I cook my chicken soup. Remember I said this? How do I cook my chicken soup faster? I put more chicken. Increase concentration. I make the pot hotter. I increase my temperature. I put MSG. I mean, when I use MSG, my chicken soup tastes better. And I cut my chicken smaller so that my chicken soup cooks faster. Right? You remember this? Easy, huh? Easy, huh? So this is what we have learned last week. And have I talked about the experiment? Have I talked about the experiment? Have I finished this last week? Have I? Have I? I say that you'll be doing this experiment in school. Have we done this? Have we done this? Have we done? Oh, you can't remember, huh? Okay, it's okay. Then let me repeat this. Okay, so you see, you have 5 factors, right? And usually pressure we ignore, right? Because pressure is only for gas. So we have 4 factors. To test these 4 factors, we have 4 experiments. You see, first experiment, concentration. Second experiment, temperature. Third experiment, catalyst. Fourth experiment, size. You see, so we have 4 experiments, 1 for each factor. And this is very easy, guys. This is very easy. Okay, so chances are you'll be doing this experiment in your school. Guys, have you done experiment in your school so far? Have you done any microorganism experiment? I'm sure you have. No, oh, you haven't? Okay. So maybe you'll be doing this lah. Because this experiment is quite important. This experiment is quite important. That's why I say these 4 factors, they are for sure coming out for your exam. I would say more important than your graph. You get what I mean? You get what I mean? This is more important than this. All right, and plus this only carries 1 or 2 marks, so it's not really worth it. Right, anyway, so let's talk about concentration. Okay, let's talk about this experiment. Okay, what is this exactly? What is this exactly? Right, so how does this experiment work? First, you take a piece of paper. You draw an X on it. You see, white paper with X. You take a white paper, you draw an X on it. Okay, and then what do you do? You put a conical flask on it, or you can put a beaker lah, whatever. You put a conical flask or beaker, and then you put these 2 solution into it. The first solution is called sodium thiosulfate solution, number 1. and you add sulfuric acid, number 2 to it. So you add 1 and 2 into the same beaker. All right. And what will happen? Okay, you don't need to remember the name for this. You just need to know what happens. When these two, they add together, they will start to become yellowish white, and they will become non-transparent. Okay, they will become non-transparent. And what happens when they become non-transparent? This X will disappear. Right? This X will disappear. And how long do they take to disappear? That's the rate of reaction. You get what I mean? You get what I mean? So if I use very concentrated solution, this X will disappear very quickly. If I use very diluted, not so very watery solution, this X will disappear very slowly. Okay, can? So the moment you put these two in, you start your stopwatch and you measure how long they take to disappear. And you observe it using your eyes here, you see? You look at the X until it disappears, then you stop your stopwatch. Okay, can? A very pointless experiment, if you ask me. And yeah, this experiment is actually very easy. You just look at the X. You just add two solution, look at the stopwatch, and you look at the X. That's all, right? That's all. And so what happens now? So we do 5 sets. We do 5 different sets. Okay, we do 5 different sets. We do from very diluted to very concentrated. This has the highest concentration. This has the lowest concentration. Hi, Charlene, how are you? Okay, we are in this experiment. Okay, we're in this experiment. Okay, you'll be doing this in your school. So let me repeat. Okay, I'll repeat this for you, Charlene. You take a piece of white paper, you put an X on it, you put a conical flask on it, and then you add these two solution. They will start to become non-transparent, and your X will disappear. The faster they disappear, the higher your rate of reaction. Okay, so guys, I have a question here. At which concentration will the X disappear very quickly? Is it 0.2 or is it 0.04? When will they disappear very quickly? Yeah, it's good. 0.2, right? Because the concentration is very high. Maybe this one will take 25 seconds. I'm guessing lah again. Maybe this will take 25 seconds. And then this will be very slow, right? This will be very slow, right? This one, because the concentration is very low, maybe this one will take 120 seconds. Right? So who has a higher rate of reaction? Who has a higher rate of reaction? This guy. Higher ROR. And this guy, lower ROR. So what does this tell us? The higher the concentration, the shorter the time, or the higher the rate of reaction. Okay, so you will for sure do this in school. You will for sure do this in school, and you do it 5 times. This is only for one factor. Okay, Charlene, you remember this? We have 4 factors we learned last week. We learned concentration, temperature, catalyst, and size. So now we are talking about concentration. Okay, later we'll talk about temperature, catalyst, and size. Okay, the same thing. Okay. Oh wow, everyone is late today. Hi Gabriel, how are you? I thought everyone is not coming today because of the holiday. Right? Are you guys going for holiday this time? You're busy at the issue, okay? Cool. Never mind, as long as you're here. Are you guys going for any vacation this week? Or next week? No? You guys are not going anywhere? Okay. I have many students going everywhere. So I can foresee that many people are not coming today. Well, but hey, we have 4 people today, so I'm happy, right? So this is my concentration experiment. Gabriel, please get the replay from me later because you missed this part. Okay, you missed this part. All right, so like I said, the higher the concentration, the shorter the time taken, the higher the rate of reaction. You guys cool? You guys cool? Easy, huh? Easy, huh? You know what's the worst about this experiment? You know what's the worst about this experiment? When you add these two together, what makes this X disappear? What makes this yellowish white is the sulfur. These two these two solution, they will create sulfur. And you know how sulfur smells like? You know how sulfur smells like? They smell like fart. They smell like fart. Acidic fart. It's like you fart with acid. It's smelly and sour. Right? And you know what's the worst part? Your eye is right here observing the X, right? And the sulfur comes straight out at you, and your nose is right here. Right? Your nose is right here. You'll be smelling the sulfur full on. And you have to do it 5 times. That's the absolute worst. Right? I hate this experiment because it's so pointless. You're just looking at this bloody X and you're smelling the fart along the way. Yay! Best experiment ever. Right? So this is concentration. This is concentration. So we look at the next experiment. We do the same thing, but this time, instead of changing the concentration, we change the temperature. Right? We use room temperature, which is around 27 degrees. We use 35, 40, 45, 50. Okay, guys, I have a question here. Which temperature will take the longest? Which temperature will take the longest to disappear? Which is the slowest? Yes, room temperature. This one will take 120 seconds, maybe. And what about 50 degrees? How long will it take? 70, okay? Maybe, or maybe like I said just now, 25. Shorter, right? So you see, the higher the temperature, the shorter the time, or the higher the rate of reaction. Same thing. So you see, we learned this last week. Higher concentration, higher ROR. Same thing. Higher concentration, higher ROR. And then second factor, higher temperature, higher ROR. Easy, huh? Easy, huh? And then the next experiment, so what does it look different? Actually, this is not so difficult. You see, I have set A and set B. You see, both I have zinc, both I have hydrochloric acid. What the difference is that this thing, the set B, has this thing called copper sulfate solution. You might say, sir, what the hell is this? When you see something funny, when you see something that you don't recognize, this is usually the catalyst. Then you see, catalyst. So one is without catalyst, one is with catalyst. So which is faster? Which set is faster? Set A or set B? Good, set B. Because when catalyst is present, your ROR will be very high. So this thing maybe takes, okay, I use my logic lah. Maybe this is 25, this is 120. Same as just now. So you see, when catalyst is present, the time is shorter or the ROR is higher. Easy? Easy? Hey, this is coming out for exam, like seriously, more than this graph. This difficult one is not really coming out. This easy one is almost for sure guaranteed coming out. Hey, good, right? Good, right? So this is what is coming out. Okay, so the last experiment, size of solid. Okay, size of solid, so size. So one, set A and set B. Set A, I'm using large pieces. Set B, I'm using small pieces. So which will happen faster? Which will happen faster? Large chicken cook faster or small chicken cook faster? Yes, B as well. Right? So this one maybe 25 seconds again. This one maybe 120 seconds. So the smaller your reactant, the shorter your time, the faster it is. or the higher the ROR. Same thing again. Okay? You guys okay? You guys okay? You guys with me? You guys with me? Hey, this is coming. I know this is very easy lah. I know this is very easy lah, but this is for sure coming up for exam. Okay, and then pressure, no experiment. We don't do an experiment on pressure because this is not really your thing. Okay, can really simple here. Nothing really much to say here. 5 factors here. Right, 5 factors here. And let me finish 4.3 also. 4.3 is just the application. We use just now the 5 factor, we apply it in real life. Okay, for example, you see, burning charcoal. Burning charcoal. So when you're having a barbecue, do you burn a big piece of charcoal or do you cut it smaller? If you want it to cook faster, if you want your charcoal to light up faster, you use smaller, right? So what factor is this? They will ask you in exam. What factor is this? Is it temperature? Is it concentration? Is it catalyst? Is it pressure? What factor is this? Good, size. Okay, next, storing food in refrigerator. What factor is this? Why do you store food in refrigerator? Okay, good. So temperature. Why do this? Because you see, when your temperature is low, rate of reaction is low. That means your microorganism, your bacteria will have slower ROR, so your food will spoil slower. You get me? I'm making my germs less active so that they are slower, so your food will last longer. That's why when you put your, like you see guys, weather is very hot lately, right? Weather is very hot lately. I put my eggs out in the room temperature, they spoil very quickly. But if I put my eggs into the fridge, they can last 1 week or 2 more weeks longer. So that's the reason. Okay, so next, cooking solid food in different size. I already say the size lah. So smaller pieces of food, they have larger total surface area, they can cook faster. Just like your satay. Pressure cooker, you see we use pressure cooker because the pressure is higher, the ROR is higher. Okay, next, industry. Guys, I want you to pay attention here. Harbor process and contact process. Please put a star here. Please put a star here, because in the old syllabus, they are also here. They have been asking this in SPM for more than 10 years. If you look at the past year papers, for 10 years, you will see harbor process. For 10 years, you will see contact process. They are almost certainly, surely coming out for your SPM. So it's a good thing, right? So guys, what is harbor process? Remember this guy? Remember this guy? I've mentioned this 2 chapters ago. Do you remember him? The founder of something, yes. Do you remember what is the big circle and the small circle? What is the cycle called? What is that cycle called? Remember nitrate, the USD in your soil? They will cycle out to become nitrogen. Yes, very good. We call it the nitrogen cycle. Remember this? Remember this? Charlene, were you here when I was teaching this chapter? It was chapter 2, I think. The last part of chapter 2. Oh, you remember? Were you here? Sorry, I couldn't remember. Were you here? It was like the beginning of March, I think. Okay, so you remember? Okay, you guys remember this guy I mentioned? He got awarded Nobel Prize because he invented this process to make ammonia. Remember this? Remember this? The evil genius scientist, the one that the wife committed suicide in front of him, the one that killed so many Jews, the one that invented mustard gas and chlorine gas and cyanide gas. Yes, remember the guy? Remember the guy? Remember I talked about Gandhi? So he was this Haber, he was awarded Nobel Prize because of Haber process. All right. So guys, ammonia is more important than you think. Oh, can I repeat again? This was the guy that invented mustard gas and cyanide gas. Remember, the one that killed so many people during World War One. Okay, this guy, remember? So he got awarded Nobel Prize. Remember? Okay. So this is the guy. Right. So Haber process is to make ammonia. Haber process is to make ammonia. Okay, guys, why is ammonia so important? Like I said, the first most important factor. Write down the usage, please, because they will ask this in exam maybe. What is the usage for ammonia? Number one, fertilizer. Like I said, 1/3 of the population, that's around 2.7 billion people, they are here today because of the fertilizer, right? Imagine a world without fertilizer, we will be in famine, we will be in hunger. Remember this? Remember this? If it's without Haber, you wouldn't survive today. 2.7 billion people will die. So you see, in that sense, okay, some people might say, sir, but he killed a lot of people. He killed like millions of people. Yeah, that's true. He killed millions of people, but he saved 2.7 billion. So in a saving to killing ratio, he's actually much better than you. He saved more people than you. He's he did more good things than you. Although he killed a lot of people, right? I mean, depends on how you want to put it out. So fertilizer, and then number two, ammonia is used to make TNT. Remember I said this? This was Haber's original intention. He made ammonia just to make TNT. Remember, to make bomb. TNT is your trinitrile toluene, which is your bomb. Oh, not only that, ammonia is used in making hair dye. Have you guys dyed your hair before? Okay, have you guys dyed your hair before? Okay, so when you dye your hair, the thing is made from ammonia. What else? You can also use this to make detergent, right? You know that blue color solution you use to wipe your window, the Mr. Muscle thing? Do you wipe your window using that blue color spray? That thing is made from ammonia. And if you smell it, it kind of smells like hair dye. And they both kind of smells like pee. Because your pee is fertilizer. Your pee is ammonia. Ammonia gives you that pee smell. You know your toilet pee smell? When you don't wash your toilet for weeks, you have that pee smell. Yeah, they are made from the same thing. They kind of smell the same too. Right? I mean, no one is crazy enough to go and smell dye because they really smell like shit. Right? Anyway, so these are their usage. Okay, so what about ammonia? So how do you make ammonia? How do you make ammonia? You just take nitrogen and hydrogen, you add it together, you get ammonia. Wow, sir, so simple. So simple. Then what makes him so great then? What makes him so amazing then? Because you see, this process might look very easy to you, but it's not easy to do. Why do I say so? Nitrogen plus hydrogen, you get ammonia. Can you see this arrow? What does these arrows mean? What do these arrows mean? Why got two one? Why are there two arrows? Anyone here knows? Why are there two arrows here? What does it mean by the two arrows here? That means they go front and back. Okay, what does it mean? This arrow means it is reversible. Reversible. Okay, this makes a problem. You see, when nitrogen marries hydrogen, they become a couple, right? But this couple, it is so unstable. This couple is so unstable. They are so unhappy with each other, they will break up. They will marry and then they will break up, right? So at the end, maybe you only get 10% of ammonia, right? You mix these two, you get 100% ammonia, 90% go back, you only get 10%. Is this a good business? Is this a good business? You only sell 10% of your nasi lemak today. Is this good business? No. That's why this thing sucks. This sucks. Until Harbour said, I found a way. Harbour said, you know what, guys? I can make sure instead of getting 10, I can make you get 90. Wow, how? How do you turn this 10 to 90? How do you make this stable? That's what he said. To make this from 10 to 90, you have 3 conditions. You need to follow these 3 conditions. That's what he said, right? Because of this, he got Nobel Prize. So what are the 3 conditions? What are the 3 conditions? Number 1, to make this thing stable, your temperature needs to be 450 to 550 Celsius. Why does it need to be this high? Because like I said, like we learned just now, the higher the temperature, what happens to the ROR? The higher the temperature, your ROR goes higher, right? You have more ROR, right? So that's why you need such a high temperature. Yeah, it's higher the ROR, right? So 450 to 550. Next, pressure needs to be 200 atm. What is atm? Okay, guys, you are living in 1 atm. atm means atmosphere. You know atmospheric pressure? You know atmospheric pressure? You are living in the atmosphere. You are living in 1 atm right now. You can breathe normally, right? That's 1 atm. So what is 200 atm? That means 200 times the pressure. 200 times the pressure. That's a lot of pressure. So why do I need such a high temperature? High pressure, sorry. Because the higher the pressure, again, the higher the ROR. Okay, so 200 atm. 200 atm. And then criteria number 3, you need a catalyst. And what catalyst are we using? We are using iron fouling. What is iron fouling? What is iron fouling? Iron fouling is your iron powder. Iron powder lah. It sounds like what it says. Iron powder, you see? Iron powder. Okay, iron powder. Guys, here's the thing. You cannot just simply change catalyst one. Catalysts, they are very specific. If this reaction needs this catalyst, you need this catalyst. You cannot say, oh, I don't want iron can, I change copper can. No, iron means iron. Okay, so these 3 conditions will make sure I get like 90% of ammonia. How the pressure works? When you have higher pressure, you press them together more. Right? Just like our ROR just now. Remember this? Remember this? The higher the pressure, the higher the ROR. That's how it works. Okay, that's how it works. Okay, so Haber process, you need these 3. You need these 3, and please memorize this. This is like almost for sure coming out for exam. Every year SPM objective question, the ABC question, you will see this question. Almost I would say almost every year you will see that. Easy, right? Easy, right? Better than you drawing graph law. The thing is so time wasting. This is so easy. You just see temperature, pressure, and catalyst, that's all. That's your ammonia. All right, that's your ammonia. That's the first industrial process. You guys okay? You guys okay? You guys following? Following? Right, so the last one, we have contact process. Contact process. What is contact process? This is to make sulfuric acid. This is to make sulfuric acid. So what is sulfuric? What is the use of sulfuric acid? What is the usage? You know your car battery? You know what's your car battery? I'm sure your dad changes his battery like once every, I don't know, 2 years. 2 years. If you don't do it, your car cannot start. Hey, you guys can drive this year already. Please take note. Next time you cannot start your car or you cannot unlock your car, this is the thing that's broken. Have you seen this before? It's in an engine bay. You open your car engine, you see this thing sitting there. It's like a black box. So this is your car battery. So inside the battery is your sulfuric acid. Right? Inside is your sulfuric acid. So sulfuric acid is for your car battery. Also, they can be used to make fertilizer, just like ammonia, to make paint, right? Sulfuric acid is in your paint. All right. So again, okay, this one is a bit more complicated. Just now, Haber process is one step, right? Now you have 4 steps. You might say, sir, we need to memorize all of this. Do we need to memorize like all of this? No. We only need to focus on step 2. Why? Because you see, step 1, step 3, step 4, they are all solid arrow, solid arrow. They just go one way. This thing is very stable, very stable, very stable. These 3, they won't break up. But this guy is different. You see, this guy, they can break up again. You remember the arrow? Remember the arrow? So this is our focus. This is our focus. Because you see, if this thing, I only get 10% of sulfur trioxide, I only get 10% of this. You see, I need to use sulfur trioxide for step 3. If I have very little step 2, my step 3 will be very little. My step 4 will also be very little. So can you see this is like a chain reaction? If I cannot do step 2, I cannot do step 3, I cannot do step 4. So step 2 is the most important. So to make sure this thing goes smoothly, I need to make my step 2 as many as possible, as much as possible. So what do? Again, 3 condition. Okay, 3 condition. Right? And to make your job easier, the temperature is the same. Right? Just now, how do you make sure you get more ammonia? 450 to 550 Celsius. Same thing. How do you make sure you get more sulfur trioxide? 450 to 550. Have to again. What do you mean? Oh, this one. I have to get a lot of this to do more of this, right? And to get more of this, I can get more of this. Can you see this is like a chain reaction step? Right? Okay, let's say I give you another example. Let's say you cook curry. Let's say you're cooking curry. You're doing step 1, 2, 3, 4. If in the middle one step you cannot do, you cannot continue. Your curry will not be done. You get what I mean? So this middle guy, we call it the bottleneck. Because if this thing is not doing well, step 3, step 4 won't go well. You get what I mean? Because you see, step 1, I get sulfur dioxide. I use sulfur dioxide to make sulfur trioxide. I use sulfur trioxide to make oleum. I use oleum to make sulfuric acid. So it's like a chain reaction. So if I break in the middle, I don't get sulfur trioxide. No sulfur trioxide, no oleum, no sulfuric acid. So my industry will not work. So I need a lot of this. So to make sure I get a lot of this, I need this reaction to be stable. So what do? Same as just now, 450 to 550 Celsius. Instead of using 200 ATM, now I'm only using 1 ATM. Don't ask me why that's the way it is. That's the way it is. And then catalyst, we are using this thing called vanadium oxide. Vanadium oxide. Don't ask me what is this. If you want to know, I can search it for you. But it is just a yellow powder. Does it tell you anything? No. It's just there to make the reaction faster. Right? What the hell is this? I don't know. What does it look like? It looks like this. Where can you buy this? I don't know. Maybe you can get this from Shopee, I guess. But what would you want this for though? It has no use for you. Right? So this 3 condition from your Haber, this 3 condition from your contact, that's all you need to know. That is all you need to study for. Right? I would say, guys, this two part is the most important part of this chapter. It's the most important part. The second most important would be the factors. And the last important one, the not really important one, is actually your graph. Sir, then I draw so hard for what? I learned this thing so fussy for what? You're right. You don't need to learn this. Right? Because this thing, like I said, very seldom in SPM. Okay, then sir, then we wasted a week last week to learn this for what leh? To have fun lor. At least you're not memorizing any stuff. You're just drawing lines for fun. Okay, what? Right? Okay, what? So you see, today's stuff is quite easy, because it's before holiday. I don't want to talk about something so heavy. So these are your five factors, and these are your harbor and contact process. Okay, you guys. So far so good. So far so good. I can't wait to go for holiday already. Okay, I've been working for 3 months non-stop. I'm just so tired. Okay. Anyway, you guys okay? You guys okay? So if you guys are okay, I am going to chapter 4 exercise. Okay, let's go to our exercise, shall we? Let's go to our exercise, shall we? I think we have done the graph drawing part last week. Okay, we have done the graph drawing part last week. So I'm not going to repeat the graph really. Let's go to question 8, shall we? Let's go to page 16. Question 8. Are you guys okay? Are you guys okay? Everyone sounds so not in the mood today, isn't it? Because the holiday mood has already set in. I know. Because yesterday is already like this. Yesterday I went to physical class. Goodness me. Everyone is so not in the mood. Everyone's physically, their body is in my class, but their mental is not. They are like somewhere else already. Yeah, I don't blame you because I would be the same too. I was a student, right? Anyway, so let's look at number 8, shall we? So factors that affect the rate of reaction. What are the 4 factors? How do you cook your chicken soup? Guys, how do you cook your chicken soup? Okay, temperature, good. Size, good. Size of reactant okay? In exam, please write full answer. Concentration, good. One more. Yes, good, catalyst. Okay, there's one missing here, but that one is only for gas. Okay, that would be our pressure. Okay. Right, B. State one factor that only affects the rate of reaction involving reactants in the form of gas. Which factor is only for gas? So that's your pressure. Aiyo, so easy. Right, so C. Calcium carbonate was reacted with hydrochloric acid in a conical flask. Oh my God, sir, why is chemistry here? You don't need to know. During the reaction, carbon dioxide gas was given off. You see, they're already telling you everything. Now, this is the key point. The reaction was carried out in 2 different temperatures. Set A 30 degrees, set B 60 degrees. This is all you need to know, right? Whatever that's happening here, that's none of your concern. Which set has a higher ROR? Yes, B. Explain the relationship between temperature and rate of reaction. Basically, they're asking you for the hypothesis. So, the higher the temperature, the higher the ROR, yes. Aiyo, so easy. You see, this chapter is like 3 marks for you. If they come out. Hey, I tell you something, guys. SPM or trial, they don't really like this chapter one. You know why? Because it's too easy. You think they will just let you get marks like that? No. So you see, when you are drawing the graph, many of my students, when they're drawing the graph last week, they were like, oh my God, sir, this chapter is so difficult. Is it now? No. Right? This is like, if I teach Form 3, they can also do one. Right. So draw a graph to show the difference between rate of reaction in set A and set B. So your set B will be very steep. Because like I said, the steeper it is, the higher the ROR, right? Gradient what? The higher the gradient, the higher the ROR. So your set A will look something like this. Can you see they all end at the same point? They all end at the same point. Please don't, guys. I have many students thinking this way. Oh, sir, B is faster. A is slower. No. No. That means you get more B and less A. No, they all end at the same point. Right? If you use 5 grams of calcium carbonate and 5 grams of hydrochloric acid, you end up at the same place. It's just that one is hotter, so it's faster. One is colder, so it's slower. You see the difference? You get what I mean? So it's not related to your end point. Please don't draw your graph like this, because even last week or last week, I already said your graph will look something like this. You see? I end up at the same point. I end up at the same point. Okay, please don't make mistakes like this. Right, so next, number 9. Before I begin, guys, can you please help me cancel column 1 and column 2? This is for chemistry. This is not for you. You are focusing on this too. You are focusing on this too. Okay, you see, you don't even need to read this. You know what is happening. So you see, the higher the concentration, the time is shorter. Hey, 19. I said 25 just now, right? Oh, I see I'm pretty close, right? And then very diluted, very low concentration. Oh, hey, almost gonna again. 115. Right? Yeah, you see, you got it. So what is the hypothesis? What is the hypothesis? The higher the concentration. Oh, for this case, you can say, sir, they write time here, right? They write time here, right? You can write both. You can either say the shorter the time, or you can say the higher the ROR. I accept both answer. I accept both answer. You just need to write one lah. Don't try to be smart, write two. So you can say the higher the concentration, the shorter the time, or the higher the concentration, the higher the ROR. Can, no problem. Either case would work. Wow, this is getting very boring, isn't it? Not gonna lie, this is really boring because it's not challenging. So C, what is the relationship between concentration of the reactant and the time taken? Isn't it the same question? Yes, it is. The higher the concentration, the lower the time taken. Hey, same answer, same question. Okay, so let's cancel D. This is for chemistry. This is for chemistry. Oh, you know what is the most difficult part about this chapter? You know what is the most difficult part? Of course, in exam, I don't think they will ask like this. They will ask about K-bar. You remember our 4.3 just now, the application one, the charcoal, the cooking meat, the pressure cooker one? That is what they will ask. Okay, realistically, that is what they will ask, because they want you to apply this in real life. Like I said, guys, if you do SPM past year, okay, you are not there yet, but just to let you know, SPM past years, these few years, they focus more on K-bar already. They are focusing more and more on K-bar because they don't want you to study without thinking. That's what the ministry say lah, right? They want you to apply this in daily life, which I think it's actually better, because the point of learning science is to put it in real life, right? So that's what the government is doing right now. When the concentration is higher, will it take time to mix in the water? What do you mean, Kavi? What do you mean, Kavi? You mean this is happening too fast? Are you saying this? Are you saying this? This one yeah, that's why there will be some error here. Maybe you will start the stopwatch late, maybe you'll start the stopwatch early. But it's okay, it's just 1 or 2 seconds. Not really that big of a concern. A good question though, that's a very good question. All right, anyway, so let's look at number 10. This is the same thing, you see. One I use marble chip, one I use marble powder. So which set is faster? Set 1 or set 2? Set 1 or set 2? Which is faster? Chips or powder? Chips or powder? Yes, powder. Because this is smaller, right? Smaller, right? So they happen faster. Okay. So, oh, you see, this time they are not measuring time. They are not measuring time, but they are measuring volume. You see, just now, they are measuring time, but now they are setting the time and they are measuring the volume. Guys, it's actually the same thing. It's actually the same thing. You see, for let's say after 120 seconds, chips will give me 17 cm, marble powder will give me 30 cm. Same thing lah, right? This is to show you the ROR. All right. So what is the RV? You see, this is what they will ask in exam instead. They will ask you for experiment stuff. So what is the RV? Yes, that's your volume of gas. Very good. Don't say time. If you say time, your answer is wrong. Because time I already set for both. So I'm not changing time. Or you can say ROR, I also accept. You can say ROR, I also accept. And then constant variable, what is your CV? What are the things you don't change here? You can just give me one lah. What is the thing you don't change? Do you need to put unit? No, you don't need to. Right, so what are you not changing? So many things. Right, you see, we have 5 factors, right? If you are changing one, the other 4 not changing. So I'm only changing the size. The other 4 is my CV. So what's the other 4? Temperature. Okay, concentration of the acid. What else? Okay lah. I don't want to say pressure because pressure is not working here. Concentration. Presence of catalyst. There's no catalyst for both. Okay, but the best is temperature lah, because both set, if I do this at 35, I need to do this at 35 too. Only then it's fair. All right, so B, what is the relationship between the size of marble and the volume of gas collected, sorry. So the smaller the size, the higher the volume of gas. Yeah, so easy. So C, what is the factor that affects the rate of reaction? What is the factor here? That would be your size. Name the gas collected. Okay, this is not really in your syllabus, but it's carbon dioxide. Okay, not important, not really in your syllabus. It's okay. Right, so you do this yourself, Do this yourself, you see, this is catalyst. So the same thing applies. Okay, let's go to question 12. Let's skip to question 12. Okay, so state the factor. Satay is what factor? Satay is what factor? Cut D for question 9. Yeah, don't do. I mean, where's question? Yeah, cut D, yes. So what factor is satay? What factor is satay? Is it? Yes, very good, size. Because you cut satay smaller, right? What about pressure? That's the answer there already. What's the factor for pressure cooker? Goodness me. Okay, pressure. Right? Do you guys have this at home? Very useful, but it's kind of dangerous, right? Because inside here the pressure is very high, and if you forgot to leak the pressure out before you open, this thing is going to explode, right? Grandma's favorite. Okay, guys, if you want to buy a pressure cooker, I suggest you buy a modern one. Oh, must in Indian household, is it? Is it? Guys, buy this instead. I have this at home, right? Buy the electronic one. I mean, it's more expensive, but it's safer because this thing is very smart. They will release the pressure for you. This one, you forgot to release the pressure. You just open like this. This thing is going to explode, and your soup will spray everywhere. Okay. Best case scenario is you screw up your dinner. Worst case scenario is you get hurt. Right? I don't know lah, guys. This thing is pretty dangerous for me. It just doesn't look safe. Okay. Oh, okay. Oh no, no. Yeah. Hey, that's the good thing about pressure cooker. It cooks your food. It cooks your soup very fast, right? Okay. Hey, this thing is freaking awesome, though. I mean, as dangerous as it sounds, lah. You can cook your soup in 20 minutes, right? Usually, soup like Chinese chicken soup cooks like 4 hours, right? Normal stove. This thing can cook in 20 minutes. I sound like I'm selling this thing. Okay. Okay. Anyway, so C. Using yeast in bread making. What factor is this? Good, catalyst. Wow, easy, huh? Keeping food in fridge. Ayo, this one I mentioned this already lah. So this is your what is it again? Oh, temperature. Yes. Okay, thank you. Okay, this is so easy, isn't it? Okay, let's look at pressure cooker. Let's look at pressure cooker. So a pressure cooker can be used to cook meat faster than a regular pot. Describe how the pressure cooker works. So they will. Okay, you know what? Actually, I forgot the point already. They will increase the boiling point of water, I think, or they turn water into steam. I think it's mentioned here. There, you see, raise the boiling point of water. Right, sorry, forgot about that. Okay, so they will raise boiling point of water. Guys, do let me know if you need BM. I'm just lazy to write BM. Raise the boiling point of water so food cooks faster. There you go. Like I said, they will very seldomly ask about pressure because it's not really your thing. This, like, remember this chapter was from chemistry. I said this before. Okay, so next, question 2. One of the instruction when using the pressure cooker is that when the time of cooking ends, the air vent needs to be opened first before opening the cover. Suggest a reason for this action. Right, so like I said, this is to release the pressure in the pot. How is this related to this chapter though? To release the pressure. Okay, so that it can be opened safely. What in the world is this? Is this question not really related, isn't it? Okay, anywho, oh guys, you know what? The remaining questions they are a bit long, so I will leave it. Okay, you know what? Because it's holiday, right? I don't want to do too much. If you have the time, please go home and finish all the exercise. Because when we come back after the holidays, I will not go to chapter 5 just yet. I will finish the exercise first before I jump to before I jump to chapter 5. All right. So please go home and do this. Please go home and do this. I will put the answer in Google Classroom. If you want, you can check it there first. If you don't want to check, it's okay. When we come back for 2 weeks later, I will discuss this with you. Maybe with like what 20 seconds. Sorry, not 20 seconds, 20 minutes. I will discuss this. Right. So guys, I will see you 3rd of May. Remember, next week is holiday, and the following week it's April week 4. It's April week 4. Guys, you're not skipping a week. You still get 4 lessons in April. That's the thing about TDC. We don't skip your lesson or whatever. Okay, so you guys have any question you want to ask? Not really, Not really, Kavi, you wanna ask anything? You wanna ask anything? Is there an O or an O? Is there a no? Okay. So guys, have a good holiday. Okay, go enjoy yourself. Do not forget this when you come back. That's my small request. And do the exercise if you have some time. Okay, so I will see you 3rd of May lah. Have a good holiday, guys. I will see you soon. Okay, so take care. See you. And bye guys. Happy holidays. Bye bye.